Hi, I'm Duncan McKean, Executive Vice President for the FMVA program here at CFI. Welcome to our course on DCF Valuation Modeling. DCF modeling is one of the most common and sound valuation techniques. What we're going to do is show you the right way to build a DCF model. We'll forecast the company's cash flows forward, discount them back to get a present value. But we're going to be so careful to avoid some of the most common pitfalls that people run into. But all the time we're going through it, we're going to be building to the highest possible industry standards. In order to benchmark to these industry standards, we'll be making reference to our financial modeling guidelines document, which is a free download and a wonderful reference document to understand the best possible standards for financial modeling. We hope you enjoy the course just as much as we love to teach it. We'll see you soon. Welcome to our DCF Valuation Modeling course. We are so excited to be sharing this course material with you. As you can see, we're going to jump straight into the model building process. It is just so important for anyone that's working in finance to understand how to build a DCF model the right way. In fact, we're going to start with a compact discounted cash flow or DCF model. It's really important to know how to construct one of these compact or simple DCF models quickly for a couple of key reasons. First of all, one of these simple or compact DCFs can really help us learn the main features of a DCF model without getting distracted with some of the complexities. The other place where these compact DCF models can be really helpful is that they can really help in situations that require some quick analysis. But not to worry, in this course, we're also going to be building a full DCF model with lots of complexity. But for now, let's dive in and take a look at what we need to know in order to build this compact model. Let's move ahead now and think about what DCF models are and how they work. It's fair to say that we often use DCF models in order to value businesses. In fact, the business value itself depends on the quantity and the timing of expected future cash flows. In fact, we can really think about a business as something which generates a number of future cash flows. Once we take all of those cash flows and we discount them backwards in time to arrive at a present value, once we add up all of those discounted cash flows, we effectively get the value of the business. So what we're really doing is we're converting all future cash flows to their present value, which is the equivalent value today. And that gives us the value of the business. Now let's think about some really important dates when we're building DCF models. In fact, there are two critical dates that we always have to consider in these models. Number one, we need to understand the timing of these future cash flows. And number two, we have to know where our valuation date is. Now, if we first think about the future cash flows, which are on the right-hand side, we need to know the dates within each year when these cash flows occur. That means we need to understand, are they occurring at the beginning of the year, the middle of the year, or perhaps at the end of the year? Now, for the purposes of this simplified compact model, we're going to assume that these cash flows are occurring at the end of each year for now. When we look at the full DCF, we're going to talk about how to control the model when these cash flows occur at different times, like in the middle of the year, or maybe 1/4 of the way through the year, for example. Now let's think about the valuation date. This is a date that we set, and we use it for the valuation. So when we refer to a present value, that present value is as of this date. So effectively, all cash flow quantities are going to be adjusted or discounted back to this date. We've already started discussing the idea of taking cash flows that are in the future and discounting them back to a present value. In the next video, we're going to dive in and take a look at the mathematics behind that and exactly how that works. We'll see you there. You may be surprised that this lesson is titled The Time Quantity of Money. In fact, the process of moving cash flows forward or backward is usually referred to as the time value of money. Here at CFI, we prefer using the term the time quantity of money because it's really the quantity of money that is changing over time. The value of money can also change over time, and that change comes about because of the inflation rate. Inflation essentially erodes the value of money over time. But for now, in this discussion, we're going to focus on the quantity and how that quantity can change over time. Let's bring in this really simple example now. The first thing that you may notice is that there's some numbers in blue font. Blue font is typically used in financial modeling to portray an input. So here we have input the first cash flow in year one of $40,000, and we've also input a 10% year-over-year growth rate for that $40,000 amount. What we can see right away with the black numbers, which are formula-driven, is that the company's cash flow quantity is increasing over time. For instance, there is 10% growth from $40,000 to $44,000, and then there's another 10% growth from $44,000 to $48,400 in year three. If we now layer on these orange-colored arrows, we can really see how this process repeats over time. For example, we grow by 10% to $44,000 in year two, and then we grow from that base of $44,000 by another 10% into year three. We refer to this repetition as compounding. So we are compounding the original amount of $40,000 over and over again through these years to get to a total of $58,564 by year five. So now let's bring in a diagram to display exactly how the mathematics works. We take $40,000 and we multiply that by 1 plus 10%, and that's how we get to $44,000. The real takeaway here is that that same process continues over and over again through the years until year five, when we get to what we would call a compounded amount of $58,564 in year five. Now, it's fairly simple and intuitive to move these quantities or cash flows forwards in time as they grow. However, in finance, it's actually more common to move in the reverse order, or take a quantity of cash flow in the future and move it backwards in time. We refer to this backwards process as discounting. Let's take a look at how that works. So let's take a look at this backwards process. Again, just as a quick refresher, we're referring to all of this as the time quantity of money. We bring up a diagram which looks very similar, but we can see that there's one key difference. On the right-hand side, we're starting with a number that is in blue font. That means that $58,564 in year five is our input, and it's our starting point for this reverse process. What we do from this starting point in year five is now reverse the process backwards, following these orange arrows. And the way the mathematics would work for this is that we take that amount of $58,564, we divide by 1 plus 10% to get the amount in the previous year, which is $53,240. If we continue this process all the way back to year one by always dividing by 1 plus 10%, we will arrive at that original value of $40,000. So as we can see here in this note, this operation obviously continues right back to year one to that starting amount of $40,000. Now we call this reverse process discounting. In fact, that's where you get the D in DCF. Discounted cash flows means we're taking the cash flows and we're discounting their quantities backwards in time to a present value. Now, to do a DCF properly, we need to make sure that we have the right cash flows and the correct discount rate. These are two areas where people often make mistakes. In the next video, we're going to dive into this and figure out exactly which cash flows to use and which is the appropriate discount rate. As we alluded to in the last video, choosing the right cash flows and the correct discount rates can be tricky. In fact, in DCF models, that is a very common place for people to make errors. Essentially, they get the wrong cash flows or the incorrect discount rates. Essentially, the question becomes which cash flows and which discount rates are in fact correct. If we bring in this diagram, we can see that we have the cash flows on the top, and we're wondering about which discount rate to use to bring them backwards in time at the bottom. Well, a person who's studied financial theory might be able to tell us that we should be using the unlevered free cash flows, and we should discount those back at the weighted average cost of capital. Now, the acronyms for these two terms would be UFCF and WACC for the weighted average cost of capital. So we may already know that in fact it's correct to pair up the unlevered free cash flow with the weighted average cost of capital. Memorizing this is one thing, but what we want to do is we want to get to the bottom of it. We want to understand exactly why these two terms are paired up together, and we're going to use them to complete a DCF model. Let's take a look. One theme which comes up time and time again when we're doing valuation work is the theme of consistency. If we're looking at comparable trading analysis or precedent transaction analysis, which are also two very common valuation techniques, consistency is going to come up time and time again. For this discussion of DCF modeling, the consistency that we need is between the numerator and the denominator. So let's again bring up the numerator and the denominator to refresh our memory. We have the unlevered free cash flow on the top and the weighted average cost of capital at the bottom. Let's take a close look now. The numerator is actually the cash flows that are available to all capital providers, meaning the debt providers and the equity providers. And what we have on the bottom is a weighted average cost, or a cost of capital from all capital providers. So the key is this consistency of all capital providers being represented on the top, the numerator, and on the bottom in the denominator. So what we really have here now is perfect consistency between the numerator and the denominator, with both representing all capital providers. When we discount these unlevered free cash flows back at the weighted average cost of capital, that gives us enterprise value, which we can bring in over here on the right-hand side. So now we understand how to pair up the correct cash flows with the correct discount rate in order to get the enterprise value. But if we're going to model out cash flows, one of the things that we need to contemplate is exactly how long are we going to forecast for in our model. Let's dive into that in the next video. So what we want to discuss here is a very common DCF modeling question. In fact, you may encounter this exact question as a technical component in a financial interview. Exactly how long do you need to forecast for in a DCF model? Really common for people to come back and say, well, you'd probably need to build a model that extended for 5 years or maybe for 10 years. Well, in fact, the correct answer to this question is that you need to forecast forever. Let's take a look at why that is so we can make sure that we understand it, and then we're going to talk about exactly how we're going to accomplish that. Now, often when we're doing valuation work, we start with the assumption that the business is a going concern. Let's think about what that means. This is an accounting term, and it essentially means that if you assume that the business is a going concern, then you're assuming that it's going to continue to operate indefinitely. So what we're essentially assuming here is that the company is going to last forever. It means that we need to forecast the cash flows forever into the future. But exactly how are we going to do this? After all, if you looked closely at Excel and moved all the way out to the right-hand side in the spreadsheet, you would see that it actually only has a fixed number of columns, which is about 16,000. So how exactly are we going to forecast forever if we're working inside of a spreadsheet that has a fixed width? Let's dig in and find out. The key to forecasting forever is really understanding that there's two parts to a typical DCF forecast, and we need to separate our cash flows into these two parts. The first part we're going to call our discrete forecast, and the second part is going to be a terminal value. Let's start by looking at part one, the discrete forecast, and how we define it. This part of the forecast shows the first few years when the company is growing faster than the economy. What happens, though, over time is that the growth for the company may slow in the later years as competitors enter the market. Eventually, the company reaches a steady state. This doesn't mean that it stops growing, but steady state just refers to when a company is effectively growing in line with the economy, or at the same pace as the overall economy. So when the company reaches a steady state and starts growing in line with the economy, that's the point at which part one has ended and part two has begun. Part two, which is the terminal value, is the part of the valuation which continues indefinitely into the future or forever. But it's not practical to forecast cash flows forever in a financial model that has a limited width. So what we do is we use a growing perpetuity formula to value the perpetual growing cash flows. So now we have a basic overview of these two parts. Part one, the company's growing faster than the overall economy, and part two, the company grows in line with the overall economy indefinitely or forever. What we'll do now in the next video is dive into each of these two parts so we can understand exactly how all the mathematical calculations work and how we're going to construct our model. Let's do it. Now, as we discussed, there are two parts or two components to a DCF valuation. Number one, we have the discrete forecast, and number two, the terminal value. What we're going to be discussing here, which is shaded in blue, is the discrete forecast. And as you can see, we have a model constructed here with a discrete forecast period of 5 years. What that means is that we expect the company's growth to exceed the overall economy for 5 years. After those 5 years, we expect that the company's growth is going to be at a steady state or in line with the growth of the overall economy. Now, as we can see, we're forecasting the unlevered free cash flows from year 1 to year 5, and they're shaded in blue. But we really want to focus our attention down to the bottom, where we show the present value of the discrete forecast of $50,623. In order to calculate that, we're using an NPV function. Now, the first thing that the NPV function is looking for is the rate, or the discount rate. For that rate, we're using the weighted average cost of capital of 13.5%. The next thing the NPV function asks us for is the values. And for the values, we are using these values shaded in green, which is our discrete forecast. So effectively, what the NPV function is doing for us is it's taking those 5 cash flows and it's discounting them back at 13.5% in order to get to that present value of roughly $50,000. Now, the NPV function asked us about the discount rate. It also asked us about the values, but it didn't ask us anything about the timing. That means that this function must be making an assumption about the timing. let's look at what that assumption is that it makes. This diagram right here will help us understand how the NPV function thinks about timing. When we feed the first cash flow into the NPV function, it automatically gets discounted back by 1 year. The second cash flow gets discounted back 2 years, and so on and so forth, all the way to the fifth cash flow, which gets discounted back by 5 years. And this is the way the NPV function works by default. So one advantage to the NPV function is that it's relatively simple and fast, because we don't have to enter in any assumptions with regards to timing. But that's also a disadvantage, because with the NPV function, we don't have any control over the timing of the cash flows or the valuation date. So let's make sure that we understand things from a timing perspective. If we think that the cash flows in year 1 are happening at the end of the year, then the NPV function will discount those back by 1 year and give us a present value at the end of year 0. If we thought that the cash flows in year 1 were happening mid-year, that would mean the NPV function gives us a present value in the middle of year 0. Understanding the timing of cash flows is absolutely critical, and for this reason, we're going to be spending more time on this as we progress through the course. For now, let's move forward and take a look at part 2, which is the terminal value.
Continue learning. Join CFI today.